So remember, it'll be a little difficult to pull out the scales and look at what 5/6 of a leather bag would be and figure out how much one of those is. But we move from the analogy to the manipulation of symbols. That's what algebra is all about. And what we want to wind up with is 1c, like one bag, right? So if we can just manipulate the numbers so that we can cancel things out and wind up with 1 times c, then we'll have it. And whatever's on the other side, that's what 1c is worth. We just need to make sure that whatever we do, that it is okay to do, that we do it correctly. And after we do that and we've done it correctly, we ask ourselves, did that help me at all? Did that make it so I'm closer? So what do we like to do first?
Subtract 8 from each step.
Subtract 8?
What? I mean, add.
Okay. Now, can we subtract 8 from both sides? Yes, sure we can. Sure we can. We can do anything the same to both sides. But then we would ask ourselves, why would I subtract 8? Because then I get negative 16. Right? I would like to cancel out that, or that negative 8. So we get 15 equals 5/6c. All right, now somehow.
Please excuse the interruption. Marcus Klusner, please go to YEP. Marcus Klusner, please go to YEP. Thank you.
Nice.
All right, so what I want to do is make it so that I don't have 5/6c, I have 1c. How do I?
You multiply by
If I multiply 5/6 by 6/5, does that do anything? 30 over 30, which is 1. I like that idea.
15 equals 1.
Oh, but I got to do the same thing on both sides. And not just 1, but 1c. 5 cancels, you got a 3, we got 18. 6 times 3 is 18. That is all, that's it.
Wait, the 13, right?
This is one. Well, this one we got rid of, like this would be, to use our analogy, like a bunch of coins hanging over here with the bag that we like something. We got rid of that stuff. But we don't have that here. We don't have like coins on this side, right? We have to get rid of that. We don't have to get rid of units. So what do we do about these two k terms?
combine like terms.
Combine like terms. So 13k minus 5k, 8k equals negative 32. Somehow I want to
Divide by 8k.
8 divided by 8 is 1.
Yes.
Divided by 8, negative 4. That's what k is. Is that you, Drew?
Yeah.
Yeah. So next is 22, 20. Those are the two where we try to find that person's mistake and fix it. So just replicate what they have. Okay, so that's the first step, or not step, the equation that's given. And next they wrote 4x equals 12. So what did they do there? How'd they get the 4x?
They just put 7 minus 3.
7 minus 3 is 4. Can we do that?
You can't do that.
7 doesn't have an x. 7 is not an x term. They're not like terms. They're not like terms. So what did they do wrong? They combined things that weren't like terms. Can't do that. All right. So that's what they did wrong. We can't do that. What would we do instead? Subtract 7.
Yeah.
Negative 3x equals
That's me. 5.
5. What? 5.
5.
5. Yeah. And then do what?
Divide by negative 3.
Divide by negative 3. X equals negative 5 thirds. 23. So what they did next was divide by negative 2. Why do you think they did that?
Because that's really the only thing you could do. Well.
Are we doing 22 or 23?
23.
Oh.
Like, why would they do that? Why would they divide by -2? Why would they come up with that idea?
They skipped like combining the like terms and I went from like -2 times x to the divided.
You saw -2 times x, they're like, let's get rid of that -2 like I've done so many times, like with -3x or 5x or 4x or whatever x. And just divide by -2. Can you divide by -2 on both sides?
Yeah.
Is that something you can do? Absolutely. Whenever I ask, can you do this on both sides? The answer is yes. You
Yes,
can always
you
do the same
can.
thing on both sides. So if we do the same thing on both sides, then we have to do it correctly. If I'm going to divide this side by -2, then I've got to divide this by -2, and I've got to divide this by -2. That would look like this. -2x divided by -2, that's nice, it's just x. But x divided by -2 would be minus x over 2. Over 2. Yes?
Couldn't you just put a 1 in front of the x?
Yes?
Wouldn't that make everything equal?
How so?
Because you just combined them?
Oh, without divided by -2.
Yeah, without doing that, you just combine them together, so it'd be,
It would just still be
Yes.
1x.
That's what I'm going to go back in a second and say, that's what we should do.
yeah, because this is just confusing them.
Well, that's my point here, is that I will tell you whenever you go to solve an equation, can I do this? If you ask me, can I do this? I will say, yeah, you can do that. But you have to ask yourself, should I? Is it a good idea? Does it help me? Does it look very helpful here? No, it looks more confusing. It looks worse. Let me undo all that stuff. Let's just go back to where we had -2x plus x. Kind of do what this guy wanted to do, but couldn't because he didn't have like terms. We got like terms here. You got -2x plus x is -x equals 10. How do we get rid of that negative? Add what? Add x?
Add 1 to each side.
Add 1 to both sides.
Divide by 1.
If you add 1, what's -x plus 1? It's -x plus 1. It's not.
Oh, there's an invisible one.
There's an invisible 1, so you just divide by -x.
Oh, so by -x?
Yes.
By -x. Okay?
Divide.
And you divide by -x, sure you can. Let's see, -1x divided by -1x
Yes.
is 1
Yeah.
equals 10 over -x.
No. You don't, no. No, it's just the -1, you don't do the x.
I'm sorry, that's exactly what you said.
I know, I
Okay.
didn't mean the x.
Divide by negative,
Yeah, just by the -1.
by -1.
Yeah. See, that's how it goes. There you
That's
go.
how it goes.
There you go.
That's how it goes. Okay.
Great catch, man.
Keep it to
Yeah, so this kind of brings up a good point. In a lot of equations that we're going to solve for a long, long time, I mean, I'm doing the same thing with my calculus class. We're doing complicated calculus-y things, but it all comes down to, in the end, getting the thing that you want to solve for times some stuff, and we divide that stuff, right? So like, a lot of times, the second to last step will look like that. Yeah, that's what I want you to do. All right. Okay, somebody leaving the class is not something we need to all chat about.
Ashley.
Some number times x, like x being the variable that you want to isolate, equals some stuff, right? What I'm trying to say is this is a very common setup for like the last step, right? This looks like the last step of a lot of equations. Agreed? And what happens when we get to this point? What do we do? What would get us there? Divide by whatever that number is. Right? And then whatever this, if it's 3, we divide by 3. If it's 8, we divide by 8. Whatever it is, it cancels itself out. We get x equals whatever that divided by that is. So look, it happened here. We divided by -1. It happened here. We divided by -3. It happened here. We divided by 8. And technically it happened here too. We divided by 5/6. Right? Which is the same as multiplying by 6/5.
Yeah, it is.
What if we had like x over a number, x divided by a number? What would we do then?
You multiply.
Multiply by whatever that is, right? Whatever that is over 1.
Reciprocal.
Sort of, yeah. I don't want to get anybody too confused. I'm gonna multiply by whatever that denominator is to cancel it out. And then we'd multiply by that number over here. So whatever that number is times that number, that's what x is. And the last one, which was like the first one we just did today, you might have some fraction times x equals the other side. So what would we do to cancel out that fraction?
Divided a fraction on the other side.
Just on this side, divide by this?
Well, on both sides.
On both sides. Absolutely, divide something by itself. Which, if we divide by a fraction, it's easier to do what? To multiply by the reciprocal. So it's the same to multiply by the reciprocal of that fraction on both sides. More like an A. We get these cancel and these cancel. We get x is equal to whatever this fraction's reciprocal is times that other side. Okay. Really common last. They're really the same thing, but they take a little bit of a different form. If we're multiplying by some number, we're going to divide by that number to cancel out. If we're dividing by some number, we're going to multiply to cancel it out. If we're multiplying by some fraction, we're going to multiply with the reciprocal of that fraction to cancel it out. Whatever it takes to get 1x on one side of the equation. Now, does that mean everybody's ready to do the review, or is there another question that we could go over? Wait, do we have a test tomorrow?
Or Monday. Dylan, it's the homework reviews that we always have.
Okay, that's what I'm referring to.
He's like,
Things are really
I was wondering since I was looking at these on the ones we had,
Yeah.
if I could like come in at lunch and review.
Sent it out to you guys, and though typically like 99% of the time you can ask somebody in the other class what we did, sometimes we'll do different things, and if I make a mistake as I did, like I just typoed, then I'll correct it for the class that I went to, but not to you guys, because that would just be confusing. So, sorry for the mix-up, but
Oh,
for the homework
it's cool.
that you guys are confused about, just trying to, it's just one-step equations. And you can do the stuff 3.2, you can certainly do the stuff 3.1. 3.2 is building up. So let's put everything away and pass in our homework at the same time. All right, first up, 14 equals k minus 3.
Doesn't matter.
We're going to get k by itself. We get rid of all numbers and anything else that's not.
You would add both sides every.
Like it. It's direct. It's to the point. And why not? That's
bam.
Yeah. Okay. Next we have
Times by.
multiply by 9.
Multiply.
What?
Wait.
No.
No.
Divide by
Divide by
nine.
nine.
I'm sorry,
Each
guys.
side.
I'm sorry. And that turns out to be 12.
Okay, there should be at most one person talking. You were talking first. So you're divided by 9. Okay. Negative 1 over 9.
Negative 12.
Negative 12. Negative 12. Okay. Do that. Divided by 9. Oh, this big?
Oh, I was gonna do the next one.
Oh, the next one. Well, I guess we're ready for that, right? Okay, what do we do?
It would multiply each side by negative 0.5.
Anytime you multiply a fraction that has something in the denominator, you multiply by that thing that's in the denominator, you always cancel the denominator out. So multiply this by negative 0.5, and what's negative 0.5 times negative 0.12? Positive 0.06.
Would you? That's what I thought, but I wasn't sure.
That is why.
What would be the grade, like, it's 0.6, they didn't.
Yeah.
say
So then it is-
0.6?
Yeah, they put 0.6 on where it's like, I know it matters, but
I don't know, like, we can go at 5.
Was that 0.065?
I don't know, like, it's close, I don't know how they got that.
What if we got like number 2?
Yeah.
So,
Should be negative. 3, does it work there?
you just get some
Yeah.
Yo.
Well, let me just kind of sidebar here. I hope that I convinced you of this. Maybe I didn't. But if you're looking at this problem and saying 9 times some number is negative 108, what does that number have to be? And you just try out some numbers, and eventually you say 12. 9 times 12 is 108, and you write 12. Well, good that you understand that you're supposed to plug something in for j, but for one thing you've forgotten about the negative. Okay. And if I see j equals 12, that's gonna get a pretty low score. If that's all I see, like that's it. I need to see some indication that you are buying into algebra. Okay? If you are still guessing and checking, you're just making it hard for yourself, and it will become difficult in the near future. It won't take very long. Okay? I know it's tempting, and I know it's just so easy, and I know that doing it the algebra way actually takes longer.
Not really.
Right? But you got to think about the tool set that you want and where we're going. All right? If I need to get from here to the back of this room, or at least that distance, I'm gonna walk. Right? That's faster. Is it faster than driving? Yes, because I have to get in my car, and I have to close the door, I put my seatbelt on, I gotta start the engine, then I gotta, like, somebody's gonna have walked over there by the time I, like, buckle my seatbelt. See what I'm saying?
You know, then you have to crash through the wall,
And you have to
then
do
you have
that.
to pay for that.
And it's just really bad.
Yeah.
Okay?
And there's big
But-
Nobody wants that.
But, so for short distances, this is an analogy, of course, for short distances, it would be faster just to walk for, 20 feet, than to get into your car, start it up, da-da-da-da-da. So yeah, that's faster. But we're not just trying to walk 10 or 20 feet. We have some long, long distances, right? Some fairly complex equations, that's the analogy, in our near future, okay? We don't want to walk 20 feet, we want to drive 50 miles, okay? We want to be able to do the easiest thing for the long run, okay? In the short run, it might be easier to just say, k is clearly 17, because if you subtract 3 from 17, you get 14.
Yeah.
When I see just answers like j is 12, when I see problem number 2, j equals 12, I have no idea what you did. And I am going to persuade you, try to persuade you to show your work, by not giving you a very high score. For one thing, it's incorrect. J is not 12, j is negative 12. Do I know why you got that wrong? Do I know if it's just forgetfulness? I have no idea.
No, you don't.
Okay? If it's just forgetfulness usually gets you a 4. But not understanding something gets you to the 3 and the 2 categories. Alright? So show your work until you become so good at 9j equals negative 108 and dividing by 9 in your head or with your calculator or whatever, but you're actually dividing by 9, not just saying 9 times something, 9 times this, 9 times that, 9 times that, oh I found it. Okay? You see that you're actually doing that work. And once you become so fast and so good and so accurate at it that you don't need to write it down anymore, then stop writing down divide by 9, but still divide by 9 in your calculator. Okay? So I can't overstate the importance of starting when it's easy to form good habits of dividing on both sides, adding on both sides, whatever on both sides, rather than just guessing and checking. Okay, so we're on to number 4, I believe it is. Negative 6 equals z over 4 minus 3. Do you think helpful next?
You would plus 3.
Plus 3,
Plus, yeah.
okay?
And then plus 3 on the other side.
Yes, sir. Negative 3 equals z over 4.
And then, and then you'd multiply by 4.
You got it.
On both sides.
You got it. So you can see is negative 12.
Are we doing the next one?
Oh, okay. I guess you're pretty eager. Yeah, let's go ahead. Go ahead.
Okay, you combine like terms, so negative 7 plus 4.
Is
Or negative 3.
negative 3 f, yes.
Equals 6. And then you would divide by negative 3 and divide by negative
3. Negative 2, that's what that is. Oh. All right, now the numbers look kind of crazy, but the idea is still the same. You got this guy. Keep in mind, look, 14.4 times m. Like that thing is usually going to be the last of what you do. You're going to get that m term alone, and then you'll divide by 14.4, right? Really common thing to do. We got to get there first. So how do we get 14.4 m by itself? Plus 5.1 on both sides. And equals,
No, it equals 0.5.
it equals what?
Yay. Good job, Jenna. You're like, so it's out of 30?
Yes.
Would 0.5 work too?
Oh, yeah.
Okay.
Yeah, Jenna.
Got two-step equations.
Oh, no.
Well, once we get past two-step, we go to multi-step.
Oh.
At some point,
Once you go three, you gotta
actually,
go back.
think about it, at some point, the number of steps, it's going to depend on who's doing the problem, because the more stuff that's in an equation, the more options there are for what I could do first. Like, even with a two-step equation, I could do it a couple different ways. Yeah. So what would you do to solve this equation? It's a two-step equation, right? Minus 4, what would you do after you minus 4? For both sides?
Okay, and then you divide two.
Divide 2, right? Really simple, familiar two steps, right? Add or subtract, multiply or divide. You know what I'm saying? Okay?
Yep.
But you know what else? I could do something else. It just wouldn't be something that would probably occur to people to do, right? Because it's not the best way to do it every time. I could just divide both sides by 2. As long as I divide these both by 2, it works. X plus 2 equals 8. Well, that just happened to work out well. Like what would not make this work out very well? Like what numbers would not be very helpful?
If the 4 was 5.
4 was 5. 4 was any odd number, right? Not divisible by 2. That would not be very fun to work with. Or if 16 was, instead of 16 was some other odd number. Yeah. It would not be fun to work with.
That was so fabulous.
But
Yes.
x equals 6. If you did minus 4, you would get 12 divided by 2 is also 6. Okay? And as we put more stuff, kind of like clutter in the way of figuring out what the variable is worth, the more options we have. Well, I did it this way. Well, I did it this way. I did it this way. I did it this way. As long as we didn't violate any laws of mathematics, then we can do it any number of ways. So when we talk about multi-step, talking about like maybe we've got 3x is 5x minus 7 equals, let's just say 13. This could technically be a multi-step problem. I have to take a few different steps. But what I do first is not what I have to do first. You know what I'm saying? Like, you might do this first, and somebody else might do something else first. I might do something else first. You might do a couple things at once. As long as we follow all the laws of mathematics, we will have no problem. We'll all come up with the same answer. So, what would someone do first?
Collect terms.
Collect like terms. Which would give us?
8x.
8x
Minus 7.
minus 7 equals 13. I would have done anything else.
I would have added the 7 first.
Well, we would have added 7 first. Now we got alternate universes, where one person in one universe collected like terms, somebody else added on both sides and had 3x plus 5x equals 20.
20.
Okay, what would this person do next?
Like times.
Sorry.
That's 7.
Add 7. Well, that person added 7 first. This person's adding 7 second. Does it make any difference?
No,
It doesn't make any difference. 8x now equals 20. Now this person's going to have to collect like terms. That gives us the same thing. And then what are they both going to do now?
Divide by 8.
X equals 10, 5 over 2. Equals 5 over 2.
Oh, man. I want Pokemon.
Yes, sir.
Could you also do 20? 2.5?
Oh, sure.
Okay.
Hey, like I said, I prefer to leave things in fractions because it makes me less afraid of fractions. Right? Just leave it. 5 over 2. 20 over 8. Simplify. Okay?
I was supposed to left 4 minutes ago for quiet.
Yeah, we're supposed to leave choir, and they were gonna announce it down here.
Well, I had choir
All right.
today.
Well, go ahead, choir.
Where?
Choir.
Thank you.
Oh,
Have a nice weekend.
Or
You guys too.
Bye.
I
It was them.
That's how you knew it is.
all right.
Okay. I do apologize.
All right. So that's what we might call a 3 step. Seems like it took 3 steps no matter which way you went. Could you add 7 to both sides like this one, like you did here? But as you add 7 to both sides, also collect like terms all at once.
Bye, Colt.
In other words, go straight from here to there. Do that. Add 7 to both sides and collect like terms all at the same time.
Sure.
Sure, why not? Do that. So how each person's work looks will be a little bit different from some other person. Throw a few more steps in there. Alright, so just everybody in your notes, just work that out. Work that out on your own, and then we'll see what everybody did.
Times 2 times 4x.
I guess it's 8x.
Yeah. And then times 2 times 3.
Good, what do we call that? Distributive property. Alright, equals?
6.
And
And then I minus 6 to each side.
Uh-huh.
Yeah, and then I divided by 8, and I got 0. Equals that.
Excellent. Can we do it differently?
I'll just 1 divide by 0.
Man.
Dude, this guy can have.
Just 2 times 3?
I ended up with 0.
Well, you're ending up with 0 as a coincidence.
Yeah.
Okay? Because we do need to distribute this here, the 4 and the 3. Yeah.
So it is
Even though it's not what? Right. Yeah, they're not alike. The like terms thing is about collecting them, adding them, and subtracting them. Multiplying, I can multiply 4x by 2, that's 8x, right? What 4x is, right, that's 4x. And then if I say 2 times that, I'm saying 2 of those, 2 groups of those. Remember when we learned multiplication, like first day, 2 times 4 was 2 groups of 4, right? So 2 times 4x is 2 groups of 4x. All we're doing is saying how many x's are there? 8 x's. Okay. Here, this is what I'm going to do right now. I'm going to think of this as like x. Like, I'm not crossing it out, I'm thinking of it as just like a big variable.
2 times x.
2 times x, so I divide by 2. I'm going to divide by 2 first. Isn't, like I'm doing the opposite of all these things? Do the opposite of multiplication, I divide. Divide 2 by 2, they cancel each other out. 4x plus 3 equals 3. It's the same. Minus 3, 4x equals 0, x equals 0.
Would that work for everything?
Well, yeah, let's look at this one. 3x, or 3 times x plus 4 equals 27. Let's just do it both ways. I mean, if you ever want to know, can I do that, just try it both ways and see if it comes out the same. Then probably the same both ways. So let's do the distribution. 3x plus 12 equals 27. Subtract 12, and we get 15. Divide by 3, and x is 3. Okay, let's do it this other way. Where we divide by 3 at the beginning. X plus 4 equals 9. X equals, oh, not 5, or 3, 5. 9 minus 4 is 5. We got 3 times something, just like we have 3 times x, we divide by 3. 3 times parentheses, divide by 3, same thing.
So if it wasn't a distributive property, did you do like the opposite, something like if it was like plus, you do like minus instead of plus, and then you get the same answer?
Could you write down an example of what you're talking about?
Never mind, I'm making too that much of something. I don't need to get on it. Yeah.
Okay. Well, here's something you definitely don't want to do, and can't do. Not just don't want to do it, can't do it. Doesn't make any sense. Just put 50, just to make sure that it does come out as a solution. Here's what you can't do. Pay attention. This 3 is inside the parentheses, right? And what's happening to the parentheses?
Being multiplied by
It is
6.
being multiplied by 6. That's very good. Being multiplied by 6. Too good a QB for that.
I was one, I was very good.
You
You
are.
guys didn't, we didn't.
All right.
Shut, make sure you
Shoot. Come on. Children, thank you. What you cannot do, since this 3 is inside of parentheses, been multiplying by 6. So is this really worth negative 3?
No, it's
No,
not.
it's actually worth more than that. So if you see someone doing this,
No, it's worth less than that.
yes,
Yeah.
it's more negative than negative 3. Very good. Okay, now, can I add 3? Just add 3 to this and add 3 to that? Can I add 3 to both sides? Yes, but is adding 3 to this negative 3 going to cancel it out?
No.
No, because it's inside parentheses that have not been dealt with yet. At the very least, you haven't dealt with parentheses yet. Okay, so no, we don't even want to try and mess with that. You want to divide by 6 on both sides, just like we did these last 2 times?
Do it.
Why not, Ryan?
Doesn't make any sense.
What wouldn't make any sense?
To like put that guys.
Well, if I divide by 6, it cancels out the 6, right?
Yeah.
It's being divided by parentheses.
This is what we've done these last 2 times. In this one, I divided by 3. Like, you could distribute the 3, or you could divide the 3. You could distribute the 2, or divide out the 2.
Yeah.
So here we are with this 6. Should we divide out the 6? It doesn't go into 50 evenly.
So you would.
So
I wouldn't like to do that first.
No, you don't.
Would not like to do that. In that case,
You'd switch.
Distributive
I
property.
would distribute. In that case, I would distribute first. I get 12x minus 18 equals 50. Add 18 on both sides. 68. Divide by 12.
Please excuse the interruption. High school teachers, please release the choir students.
Oh, that was-
Please
there
our
was
choir
one.
students. Thank you.
1 minute away now. 2?
What?
Go away. We don't like you.
Okay. So now we still do wind up with this not great fraction, but at least it was in the last step that we did that. Rather than divide by 6 first and have to deal with that 50 over 6, the entire equation. That would be some pain. All right, let me give you another one and see what you guys do. In his hand?
Yeah, so I actually think I might have gotten this wrong.
Oh.
So
What'd you do first?
So I added 5.
What do we all say to that? Would that be good?
No.
Yes. Yeah, you could do that.
Okay. Add 5 to both sides.
And then I did the distributive property.
So this is 28. Then you did the distributive property.
Got 9x plus 21 equals 28.
Uh-huh.
And then I minus 21.
Okay. I don't see any problems with any of this so far.
And then I divided both sides by 9. I got 7 repeated.
Me too.
7x.
Yeah, that's what I did.
Oh.
But like the other
I
one.
got 8 9s.
Alright, so.
I did it right. Sorry.
I don't know.
She's in 30.
It's laptop. Nice. Okay. Do we have to get one of these for the entire year?
If you use it up, then I'll give you another one.
Really? Okay.
Just like a coffee shop. I'll give you another one if you use one. Or my favorite, Cafe Rito.
Oh,
Just chilling.
Pardon me?
Sure. There you go. That works. Did everybody do it that way?
no.
No. Naturally not. Hey,
Wait, how did you
we got some. Where are you going? Zach. What? You got somewhere to be? You're just cleaning up. That's Jeff.
How did you get 28?
How did I get 28?
Oh, never mind.
Okay. I thought I did something wrong for a second. That's definitely not.
I was like, I did that, so.
All right, let's talk about doing something else. Approaching it a different way. Because I heard some people say, no, I didn't do that.
You do the distributive property first.
Oh, you did the distributed property first. Does that make a big difference?
No.
No, it's the same thing, right?
Yeah, pretty
But
much.
instead, what did you do right now?
I did like terms.
Like terms of numbers,
Yeah.
right? 9x plus, yes,
Oh,
16 equals 23.
And I subtracted 16 from both sides.
9x equals
7.
7. X equals 7 over 9.
Yeah.
Of course, it's all the same. True.
Would 7 or 0.7 repeat the for an answer?
I really, like I said before, I really prefer it to be in fraction form. If you write 0.7 with a line over the 7,
Yeah.
I'm gonna mark you wrong unless I've asked for a fraction instead of a decimal. But if I have the choice between 7 ninths and 0.7 repeating, I would prefer 7 ninths. But again, I'm not gonna mark you wrong because it is correct.
Okay.
I just feel like we have an over-dependence on writing things in decimal form and feel an anxiety when it comes to fractions. And so I encourage you to, get locked in a box with a fraction and don't get afraid of fractions anymore.
I like fractions.
If you like fractions, you have a pet fraction at home and you're perfectly comfortable with fractions.
You do have a pet
But what if my fraction is
I have
five?
half a dog.
My pet fraction got to play a car.
Half a dog. Like a horse, that's fractional.
I got a puppy.
That's
Oh my
what-
god, there's actually dogs with 2 legs. He could be a fraction.
How would you do that?
Alright, so what do we do about having variables on both sides? You guys are getting really tired of this, having to compete with something ridiculous that's so fleeting. Try and convince you that you should learn this. So how do we deal with variables on both sides? Just before we say anything about that, let me use the analogy we've been using. So I'm going to recreate this equation with a good old set of scales.
Oh.
I'm just going to wait until we can all stop and just chill. Pass notes, that's fine, but let's just read them silently. Okay, we got 3 of these things on this side. Okay, now how are we going to write -7? Yeah?
A black coin.
Okay, a black coin.
A dark one.
So let's make some coins that are black, and they'll represent, what do they represent,
A
Dimitri?
negative coin.
A negative coin, okay? That works. So, let's see, we got -7, so we'll get 2 more going here, and then one more. Alright, so there's 7 negative coins. Right, a black coin is like the opposite of a gold coin. Alright, over here we have 1, 2, 3, 4, 5, and 9 positive coins. There's 9 positive. Okay, maybe it immediately occurred to you what you would do with the variables on both sides. Maybe it didn't. For those of you who didn't, take a look at the scale now. We want to get a single bag alone on one side. So how can we do that and keep it balanced?
First thing is first, I think you take away 3 bags from each side.
Right? If I take, well, yeah, if I take 3 off of this side, there's no more bags over there, right?
Right.
Okay, but right now, what's the scale looking like?
It's really low.
It's all lopsided. I need to take 3 off of this side too. Now it comes back and it's level. Yeah?
I just want to know how much are the black coins worth? Or are they?
7.
One black coin is worth the
One
opposite
negative
of 1 coin.
So no, so it's a negative.
All right, all right.
So if I threw a gold coin and a black coin, they would explode and cancel each other out.
Like inside
Yes,
Explode.
matter and
Zero
antimatter.
all over.
So let's imagine it's less violent than matter and antimatter. So now, we only have bags on one side of the scale, and all we have to do now is get 1 bag by itself. And it's a lot like any other equation you see. How do we go about getting those bags by themselves? Drew?
You take away 7 dark coins.
Am I worried about these? I'm worried about getting these bags by themselves.
Okay, well then you take away all of those coins.
Take away these?
Yeah.
So I need to take away 2 from here.
Mhm.
So I also need to show that I've taken away 2 from here. So I need to like bring in 2 more black coins. Right? And then take 2 away from here. I need to do 2 away from here. I need to take away 1, like 2, 4, 5 more. So I'll just copy these guys. Right? So I took away 9 from here, which means to take away 9 from something that's already negative, and that's just go more negative and even more negative coins. Right? Okay. So now we have 2 bags here. Yes.
Couldn't you have like added 7 on that side too? Or would that not work?
Like
Well,
plus 7, and then that cancels it out, and then plus.
if I back that up to right here, no, here, and I say, how about if I add 7 points to this side and add 7 points to this side? What will I have over here?
Oh, nothing.
Just nothing, and then more coins together with these
Okay.
bags, yeah?
Yeah.
Okay, so, there we go. Because we're trying to get the bags by themselves. So now we have 2 bags here and a group of negative coins over here. Yeah.
So you must know that it's the scale's even, right?
Yep, of
So
course.
that you must know that the amount of black coins is divided by 2.
Right. I got
So there's
2
nothing.
groups of a bag, right? 2 groups in one bag. So I'll have to split these into 2 equal groups. Let's see if I can do. Let's see, I need to do that, and then this, I think.
Yeah.
That'll split them into 2 equal groups.
Yep.
So I can see it, there's two there, there's two groups here, so one of these groups must be the same as one of these groups. Well, that's dividing there too. When we break things into groups, we're dividing.
Right.
Let's see what that looks like.
7 on that side and 8 on that.
Huh?
No, it's not.
So x equals
Yeah.
7, 8,
And so,
and 8. It's hard to see, but I took this
I
group
see,
around
I
that
see,
one.
I see.
Okay, let's look what it looks like when we do it with symbols. Right? We took 3 bags off of each side. That's just minus 3x on both sides. Negative 7 equals 2x plus 9.
Subtract 9 from each side.
Yeah, we subtracted 9 from that side, and then we had to like put more negatives on that side. So we're at negative 16. 2x equals negative 16. And then we divided this into 2 groups, divide this into 2 groups. So one of these groups is equal to negative 8. If you have variables on both sides, it's like a set of scales that has bags on both sides. We want to clear off the bags off of one side, so that only one side has any bags on it. So we'll take off bag to bag. One bag on the left, one bag on the right, one bag on the left, one bag on the right, until there's only bags on one side by themselves. Let's try, see what we come up with if we all approach that problem. Okay, now, again, there will probably come a time in the future where you're solving some equation, you'll ask me, is this what I'm supposed to do first? Is there anything that you're supposed to do first?
Only in PennDOT.
No, you can do it in different ways.
You can do it in different ways. I guess only in PennDOT. Only in the order of operations there's some things to do first. Sort. That's almost always true.
Yeah.
That's what that video was about, right?
Huh?
Did we watch it here?
Yeah.
It's not a strict thing. It has to be. It's just something we would agree to. Well, okay. So what can we do first? Somebody's done something first. What do you do first? Dylan.
Distributive property?
Distributive property. So 2x plus 6. And minus 5 there. 3x plus 6.
And then I added the like terms on the left side.
So you got 2x plus 1 equals 3x plus 6.
Let me keep going.
Yep.
I subtracted 2x on both sides.
Careful, I saw some minus 2, just minus 2. And it seemed for the people that I saw do that, it messed you up. Okay. 2x minus 2x is 0. Got 1 there equals x plus 6.
And I subtracted 6 on both sides.
6 minus 6.
I got it.
Negative 5. I don't know why it didn't show up. Exactly. Correct solution. Was it the correct way to do it?
No,
It was a correct way. There's no correct, the correct way. Right? Anybody else do something? What are some other first steps?
Subtract, add 5.
Add 5 to both sides, then distribute, then move the x's around, then do that. Anybody do anything besides distributive or add 5 on both sides first? Be surprised. What did you do first?
Well, I didn't do that first, but you could, I guess, solve the other side, you could do -6.
Yeah, you can do minus 6 on both sides, get negative 11 over there. That can happen for sure. Yeah, lots of different options. No one correct way to do it. The only thing that's not correct is to do something like 2x plus 6 is 8x. Well, that's not correct. That's not a matter of what I'm supposed to do first or second or third. That's just not correct mathematically. Okay, let's do one last doozy. Okay, see how we do.
I like it.
Let's do 3.7 plus 5.2 minus 10.6 equals negative.
I'm gonna need a calculator for this.
Yeah, I would use a calculator. 4.9x plus 2.7. Okay, go ahead and solve for x. Something like this. You just need to, hey, is talking gonna help?
No, it's
Talking over me gonna help?
No.
Just one little step at a time, right? I see a number, I see parentheses, okay? And then, guys, I'll distribute that, right? So 2.5 times 3.7, that gives me 9.25x, plus 2.5 times 5.2, gives me 13, still minus 10.6, equals, distribute the 4.3, 4.3 times negative 4.9 is negative 21.07x, 11.61, distributed to 2.7. Okay, add these two together, 9.25x plus 2.4. Have a good day, everyone.
I can't take it. What? I said I can't.
I was like, so.
You are the
You just see him on the cover wearing the watch t-shirt.
Jenna?
He's the best at doing this.
I don't get it though.
Thank you, Brett, for the $1.
I don't get it,
Hey,
Shane.
Jack, I got a deposit for
Your living proof thing.
Divide by 30.
Hold on, wait.
Wait, I'm just going right here.
More money for the
You really like that.
No.
I do.